At the farthest edge of our solar system lies Neptune, a world of blue storms, unseen energy, and quiet power. It's the eighth planet from the Sun, orbiting more than 4.5 billion kilometers away, where sunlight needs over 4 hours to arrive. Here, warmth fades, and time itself feels slower. Neptune isn't just another ice giant. It's the only planet discovered through mathematics before anyone had ever seen it. That alone makes it a symbol of human curiosity, proof that logic and imagination can reach places our eyes cannot. Its deep blue glow comes from methane high in the atmosphere, but scientists believe something else intensifies that color, an unknown component still under study. Winds there move faster than sound, sweeping across frozen clouds with unmatched speed. Despite its distance, Neptune remains one of the most active worlds in the solar system, a paradox that challenges everything we know about planetary energy. Named after the Roman god of the sea, Neptune now rules a much greater ocean, a cosmic one. From this far, the Sun is just another bright star, yet Neptune still reflects its faint light like a sapphire adrift in darkness. It stands as the last guardian of our planetary family, silent, distant, and waiting for us to uncover its secrets. Long before a telescope ever found it, Neptune existed only as an equation. In the early 1800s, astronomers tracking Uranus noticed something strange. Its orbit didn't match predictions. The planet was drifting, as if pulled by an invisible hand. That mystery led two brilliant minds, working separately, to the same conclusion. There had to be another world, one never seen, tugging from the darkness. In England, a young mathematician named John Couch Adams started the impossible, calculating where that unseen planet should be, based solely on Uranus's motion. At the same time in France, Urbain Le Verrier followed the same trail of logic, refining the math with relentless precision. Both men pointed to nearly the same region of the sky, a small patch within the constellation Aquarius. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. On the night of September 23, 1846, German astronomer Johann Galle turned his telescope toward that patch. Within less than an hour, he saw a faint blue disk that moved against the backdrop of fixed stars. It was almost exactly where the calculations said it would be. For the first time in history, a planet had been found not by chance, but by mathematics alone. The discovery sparked pride and debate, with Britain and France each claiming the triumph. Today, both Adams and Le Verrier are honored as co-discoverers, and Neptune stands as a testament to human logic reaching beyond sight. It proved that the universe follows patterns, and that the human mind, guided by reason, can trace those patterns to the edge of creation itself. Le Verrier proposed the planet's name, Neptune, after the Roman god of the sea, fitting for a world wrapped in blue and hidden in the depths. That name remains one of the most poetic in all of astronomy. It connects myth and mathematics, a reminder that every breakthrough begins with imagination, bold enough to chase the invisible. From that moment, the solar system had 8 known planets, and humanity had learned something profound. We don't just observe the universe, we predict it, calculate it, and reach it long before we arrive. At first glance, Neptune should be calm, too far from the sun, too cold, too dim to stir. Yet this distant world refuses to stay quiet. Its atmosphere roars with the fastest winds ever recorded in the solar system, reaching over 2,000 kilometers per hour. Here, air moves faster than sound. Scientists still don't fully understand how. At this distance, Neptune receives barely 1,000th of the sunlight that Earth does, almost no external energy to drive storms. And yet, the planet's upper layers churn constantly, its clouds shifting and reforming within hours. Neptune breaks every rule of planetary weather. The answer seems to lie deep inside. Measurements show that Neptune gives off more than twice the energy it receives, releasing heat from an interior that remains active even after billions of years. That hidden warmth drives enormous pressure differences, feeding winds that encircle the planet in a restless dance. The result? A world where the coldest air meets the most intense motion. Among Neptune's tempests, one stands above all, the Great Dark Spot. When the Voyager 2 spacecraft arrived in 1989, it captured a vast storm roughly the size of Earth. Unlike Jupiter's long-lived Great Red Spot, Neptune's version was fleeting. By 1994, it had vanished completely, replaced by another in the opposite hemisphere. Since then, the Hubble telescope and other observatories have seen several appear and disappear, each lasting only a few years. These short-lived giants show that Neptune's atmosphere is dynamic, flexible, and unpredictable. Even its color hides mystery. The familiar blue comes from methane absorbing red light, but the tone is deeper and richer than Uranus's, too vivid to explain with chemistry alone. Researchers suspect an unknown component enhances the hue, possibly linked to haze or particles formed by sunlight in the upper atmosphere. Whatever the cause, Neptune's blue remains unmatched, a visual signature of mystery. Its magnetic field adds to the puzzle. Tilted nearly 47 degrees from the planet's axis and shifted far from its center, the field loops through space in a twisted pattern that defies simple models. It may arise not from a solid core, but from layers of electrically charged fluids swirling within the planet's mantle, a magnetic storm hidden beneath the clouds. Every measurement, every image, reveals the same contradiction. Neptune should be still, but it isn't. In the quietest, coldest part of the solar system, energy never sleeps. Among Neptune's companions, one moon stands apart, Triton, a world that defies every rule. It moves backward, orbiting in the opposite direction of Neptune's rotation, a clear sign that it didn't form there. Triton is a captured wanderer, likely a relic from the Kuiper Belt, drawn in by Neptune's gravity long ago. Its arrival must have reshaped the entire Neptunian system, scattering or destroying earlier moons and leaving Triton as the dominant survivor. Today, Triton contains more than 99% of the mass of all Neptune's moons combined. It's a world of frozen nitrogen and silent power, 2,700 kilometers across, nearly as large as our own moon. But what makes Triton extraordinary is not its size, but its activity. Despite surface temperatures near 235 degrees Celsius, Voyager 2 revealed a landscape alive with motion. The spacecraft captured towering plumes of nitrogen gas, geysers rising 8 kilometers above the surface, driven either by sunlight warming thin layers of ice or by internal heating caused by tidal stress. These jets paint dark streaks across the pale surface, proof that even here, far from the sun, geological energy still breathes. Triton's face tells a story written in ice. Vast plains stretch across its southern hemisphere, fractured by ridges and valleys shaped by slow tectonic movement. A region known as cantaloupe terrain looks like the rind of a melon, its pattern formed by surface collapse and resurfacing. Few impact craters mark the land, evidence that the surface renews itself, erasing ancient scars. Above this frozen ground, a thin atmosphere of nitrogen drifts, mixed with traces of methane and carbon monoxide. It's fragile, less than 100,000th of Earth's pressure, yet enough to form delicate clouds that hover over the horizon. As seasons change, frozen gases on the surface slowly vaporize and recondense, creating a rhythmic cycle that might last for decades. Beyond Triton, Smaller moons like Nereid, Proteus, and Galatea orbit in eccentric and irregular paths, likely remnants of the chaos Triton once caused. Proteus, the largest of them, remains oddly angular, never collapsing into a perfect sphere. Between these moons stretch Neptune's faint, dark rings composed of fine dust and organic material. They are not uniform bands like Saturn's, but broken arcs, bright segments named Liberté, Égalité, Fraternité, and Courage. Their structure stays stable thanks to Galatea's gravitational rhythm, locking the particles into place. Altogether, Neptune's system feels like a frozen ballet, moons, rings, and storms moving in complex harmony, shaped by a single captured moon that changed everything. Triton's rebellion against its planet's motion isn't just a curiosity of physics, it's a reminder that even in the farthest places, chaos can become beauty. Neptune, the last great planet of our solar system, still guards more mysteries than answers. For decades, it was a distant blue dot, a frozen world seen only once when Voyager 2 passed by in 1989. Since then, no spacecraft has returned, and for more than 30 years, Neptune has waited in silence. Until now. With the arrival of the James Webb Space Telescope, that silence has begun to lift. Through Webb's infrared vision, Neptune's faint rings, unseen since Voyager, appear with stunning clarity, stretching like ghostly halos across the planet. Between them, delicate arcs shimmer with ice and dust, shaped by Neptune's small inner moons. These structures shift subtly over time, proof that the planet's surroundings are not static, but alive with motion. Webb has also revealed something no one expected: auroras glowing away from the poles, flickering at mid-latitudes. They appear where sunlight is weakest, driven by Neptune's magnetic field, one of the strangest in the solar system. It tilts 47 degrees from the planet's axis and is offset far from its center, twisting through space in complex loops. The new images show how charged particles follow these distorted paths, sparking light high above the clouds. It is a glimpse into a magnetic system unlike any other, chaotic, elegant, and endlessly dynamic. But the surprises don't stop there. Temperature readings from Webb indicate that Neptune's upper atmosphere is colder than once thought, nearly 10 degrees lower than previous estimates. This shift may explain why some regions appear dimmer or brighter over time, suggesting that Neptune's climate might change in slow seasonal cycles. In a world where 1 year lasts 165 Earth years, those changes unfold so gradually that a human lifetime barely spans a single season. Even Neptune's famous color has been re-examined. New analyses combining data from Webb, Hubble, and ground telescopes reveal that its true hue is softer, a calm green-blue rather than deep cobalt. Voyager's instruments exaggerated the contrast. The real Neptune is subtler, more serene, like sunlight filtered through deep ocean water. Yet beneath that calm exterior, Neptune remains fiercely active. Its winds still race at supersonic speeds, its atmosphere forms and erases vast storms, and its interior radiates more heat than it receives from the sun. Something inside continues to stir, energy rising from hidden layers of compressed ices and superheated fluids. Future missions, including NASA's proposed Neptune Odyssey, aim to return and stay, orbiting for years to study its atmosphere, rings, and magnetic field in detail. Such a mission would transform Neptune from a distant icon into a living world we truly understand. For now, we can only watch from afar, through the eyes of Webb, through the quiet reach of our instruments. And as that faint blue light travels 4 hours across space to reach us, it carries a message. The frontier is not a boundary. It is an invitation,